Hi, welcome to the Introstat lab sessions. And this video, we're going to cover lab number 6, the regression analysis. For the lab number 6, we have 3 other videos. So you should review the 3 other videos first to understand what is a regression line and also all the other terms related to the regression analysis. For example, what is the least square method and what is SSR and what is the predicted value, those things. Okay, so this video, we're going to focus on how to use the R try to help us generate this regression analysis and how to read the R report to get our information out. Okay, so in order to introduce R, I'm going to use an example to show us what type of the code I need to do for the R's here. Okay, so let's go back to this example I have put here. So for this example set, the manager of the purchasing department of a large company would like to develop the regression model to predict the average amount of the time it takes to process a given number of the invoices. So over a 30 days period, data are collected. And so the number of the invoices processed and the total time it taken. So data is listed below. So we have 30 days, and this is how many invoices. And the first column here, this is how much time, how many hours, you try to, you spend on that. So basically what we are looking for is here, we are looking for a regression model. Y is equal to the B0 plus B1X. And what is the Y? Y is the times, right? So Y is the time. So this is we call the, if you remember, in the analysis, we call the Y, we call the, this is a response. So this is our response variable. And the Y is the total processing time given the number, X is the number of the invoices, right? So the X here, if you still remember, so the X here, we call this is a predictor. Right? So if you give me the invoices, if you give me 20 invoices here, I hope that I can use this relation and try to predict how much time it will take, right? So this is what the number of the invoices here is X. The time to predict is Y. So I want to find this relation Y equal to the some linear regression, some linear line is the, how many invoices you can predict how much times here. Okay, in order to do these problems here, to do the regression problems here, I also list a few key steps here for you to follow. The first steps here is we always from the previous video, we said when we do the regression analysis, the first, let's do a scatter plot. Let's just take a look at the plot first. Okay, so get an idea, and then we can generate, a regression line for that. Okay, so let's take a look at how do we do a scatter plot here, right? So this is the first things here. First, let's try to do a scatter plot here. Okay, so now let's take a look here. Let me copy these things here. Okay, so let's go to the R's here. Okay, so the first things here, in order to do a scatter plot, right? So I need to input my variables here. So I have invoices and I have a time. So the first variable I want to input is invoices here. Okay, so let me see here. I have here, copy and So I copy here. Let's see here. Okay. So, well, where did that go? Why it's not working here? Let me see here. Okay, so here. All right, so here. So the first things that you want to do is you want to input. So you type the invoice. Okay, so I guess that's just okay. So in here, right? So you type the invoices here. Okay, let me see here. So you give a name. See here. So I give here is invoice. I see. Remember, the R is pretty sensitive to the lower uppercase. So you can give any names you want. Now here, this is the key point here. So you need to put a C here. Okay, C, then you parenthesis. Then you input your data, the invoice data from the file I just show you, right? So it's 149 da 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 da, and then you input that. Okay, so now after you finish you input the invoice, then you just go here, then you just said enter. Okay, so after you enter it, you can check here. So you back here, your R going to show you, see here, say, hey, this variable I have a generator is invoice. How many numbers here? 30. So from here, you're pretty sure maybe you did not input wrong, you missed one or two, no, so you give you the 30. Right, of course, that you still can have some type of error layer, right? But you just be careful, double check that. Then the next thing here from the data we know is the times, right? So that's my y variable. So how much, how much time it will take, right? How much time it will take to, to go back to the. Okay, so here back to the R here. So now you create another variable. See here, I called is time, right? So like I said here, you can give any names you like. If you want to give it X, Y, you can do here. So I give this variable is a time. So for input data, you put a C here, right? So it's a C and parenthesis, you input your time. And after you input that, then what you do here, you hit enter. Okay, so you hit enter, and then you can check to see, did you miss any data points here? Then you go back here, you say, oh, here, this is my variable time, and I got a 30 variables, 30 values there. So you say, okay, I know pretty much I input it right. Okay, so here, the next things here is we need to do a scatter plot, right? Okay, so now let's go back to here. So this is the scatter plot. Okay, so this is the statement I used, right? So this is the code. So you will say here, this is you just do a plot. PLOT and the invoice time. So in here, the first, be careful here, the first one here, the invoice you put here is your X, right? So the second one, so it's XY, all right? So this is XY input. Then you can give a label. So you can say the X, you can label that, say X equal to number of the invoices and Y is equal to times here. Okay, so this is how do I do a scatter plot. Okay, so now let's enter that. Okay, so you enter, well, where to go? See here. Okay, so you enter that. Okay, so see here, after you entered it, so in here, this is the scatter plot. It will show you, right? So this is the scatter plot. So remember, this is my X, right? So this is the number of the invoice, and this is the time. So you kind of see, it's kind of have a kind of a like uptrends, right? So kind of have uptrend, but it's not very strong here, right? Okay, so now you say, okay, how do I hit? How do I, okay, so this is my the scatter plot. And then the next thing is here, I kind of see a kind of a going uptrend. So I want to fit linear regressions here. So the second part here is how do I fit linear regression on the, on this scatter plot. So the statement I'm using here, okay, is we use this word, we said a bit line, so ABLINE here. Okay, so that means I'm superposed a line to this scatter plot. And also be careful, this one here, this is LM, right? So the LM, that means the linear model. I want to get a linear model. I want to get a line instead of get a curves here, right? So the linear models here. So when you do the linear model, so you put a Y. So this is Y to X here. So the linear models here, like it's a linear model, is Y to X. So the Y is your Y-axis, X is your predictor, right? So it's your X-axis. So in this problem, our Y is time. So you put a time, then you use this notation tilde, right? So you use this notation tilde to the invoice, okay? So this is the statement, it's a pretty handy statement. So AB line, and then you say that means I'm superpose this line, and this line, what type of the line? Hey, I'm generate a linear model. So I want to predict the time by using invoices here, right? So it's Y over X, be careful. If you do the wrong one, then your line will be the, it will be XY. So that, so that's why be careful, it's time and the invoice. You see here, okay, after you hit enter, so this is, what is here? This is the regression line we want. So that's pretty cool, right? So we kind of eyeball that, we see, we have uptrends here, right? And then the next questions here from our previous videos, we say, hey, if you tell me this is the regression lines here, right? I want to know what is this equation looks like, and what is the other information I have here. Okay, so I want to get more information out from here. So now we really start to do the linear regression analysis here. So that's okay. So how do I do that? You said, okay, so here you said, okay, so it's, okay, so you said, I want to call, this is the, okay, so you can give any names you want. So in here, I want to call this result. I call this fit. So this is the, what is this result come from? So this notations, right? So you use this notation. What is this result come from? So that means, what is this result come from, right? It's come from by using the linear model times related to the invoice. Okay, so I want to find all the results from doing this analysis. The app line just give us a visual, right, presentation, the line superimposed into a scatter plot. Then the fit here will give us the analysis result. Like I said, the fit is any names. If you like it, you can say John, Mary, right? So that means your analysis result. You can say my, so then it will be your analysis result. Always say John, right? So that's what we call it, the fit. All right. So that means that will give you all the good information for that. So you hit enter. And now the next things here you want to do is you want to take a look at your fit results. All right. So then you will say here, you say, okay, give me a summary. Right, so you say, hey, give me a summary. So you say, okay, summary. So give me a summary about this, the regression I just did. So whatever you put in here, you summarize is here fit, right? So if you say John, if you define that this is John, then you say summary John. If you define that this is Mary, then you say summary Mary, right? So whatever the names here you give, okay? So now here. Now this one's here, boom, wow, so that we have this result. This is a pretty good, the results here, right? So in here, so here is the residual summary. Okay, so now let's take a look at how do we interpret those things. So this is the residual summary, and to tell you the minimum residuals is negative 1.57, maxima is 1.77, and we said from the previous videos, we said the residual and has to be, it's a normal distributed, right, with the 0 and what? And with 0 is standardized normals, right? So as long as they are within the plus minus 3, so I know they are is randomly jumping around in the normal distribution, so that's good. So I don't have any residuals is extremely large or extremely small. So that's good. So you can take a look. Also showing you the median is a negative 0.00672. So it's very, very close to 0. That's good, right? Because we talked before, we said the residuals here, if this is 0, your residual should be randomly jumping around the zeros, right? So the median is 0. So that's a good sign here. So your model probably is good, right? Okay, so now the next thing here is very important, is this coefficients here. This coefficient, this is the one you will decide these lines here. So you will see what is this line? How do I write it? Okay, so this is the concept you need to use, right? So this one's here. Okay, so this one's here. Okay, so how do I write it? All right. So those are the two numbers I need to use here. Remember, a while ago we said y is equal to the b0 plus b1x, right? So y is the time, x is what? X is the invoice, right? Okay, so how do I find this line? These lines here, the B0s here is what we call the intercept. So let me color code that, right? So this is intercept. So this one is equal to 1.218773, all right? And plus, what is this? B1 is the slope, right? So B1 is in front of the X is invoice. So that's why you use this constant associated with the invoices here. Okay, so it's a pointer, what? So it's a pointer 0.05808 X here. Okay, so that's why you can write as here. You can say, what is this line? You will say, hey, this line is equal to y is equal to the 1.218773 plus 0.00580x. That is how do we find the regression lines here. Of course, they will ask, what are all these things here? Those are the different analysis we talk about to test the significances. So in here, we're not going to discuss that. We just want to let you know, how do you find, how do you find this regression line? By looking the regression output, right? Okay, so the next things here we want to look is this number. Remember the previous video we talk about R squares, right? So this is the color things here, R square. So this is 0.199. So in here, the R square is equal to 0.1996, right? So it's approximately to 20%, right? So this is equal to the 19.96%. So approximately to the 20%. So this R square is the coefficient. So we call this a coefficient of determination, right? That means what percent of the variation about Y, that means the time in here was contributed by the variation of the X. X is invoice. So in here, this R square is kind of small, is 20%. That means only 20% of the variation, the time spent, was contributed by the number of invoices here. So because this is only contributed to the 20%, so there are still 80% of the variation of the Y, the variation of the time, I do not know, right? So that means I probably missing some very important predictor variables, right? So the X is one of the predictor variables, is the number of the invoices here, okay? So maybe we are missing some other important, the variables. It's like, for example, it's the people who dealing, who take care of those invoices here, the number of the years the people work on. Maybe more experienced people, they can shorten the time, and for the starter, maybe take longer, right? So that's why we know we are missing some important factor, the predictors in this model, because right now it's only explained 20% of the total variations here, okay? Now, the next things here, we want to, we want to do here is, so from here, right? So we also want to take a look, what is the SSR is the sum of the squared residuals. That's what, in the previous video, we talk about it, right? So from this, the summary of the fit, we know what is the very important, how to write these equations, right? And we also know find the R squares, right? Then the next ones here we want to do is, we call this the ANOVA, all right? So the next things here we want to analyze, we call this ANOVA. That means analysis of the variance of my fit. So like I said, if you call your analysis is John, you just say ANOVA John. If you call your analysis Mary, you just say ANOVA Mary, right? So it's ANOVA is ANOVA, all right? So you hit it. Whoa, they give us this result. This is the one we called is analysis of the variances here. And the analysis of the variances here, right? So here, the few things we want to see here. This is the things here, okay? Okay, so this is the things here, the residuals here. So we want to know is this number 20.5375. Okay, so this is how to remember in the previous video we say we care about the SSR, right? So this is how do we read the sum square of the residuals, right? So sum square of the residuals is what? This is 20.5375. So basically this is measuring, this is your regression lines, right? And those are what? Those are the real value. They measure the total distance variation from the observing, to the fitted, right? So this is how do you find it, okay? And then the next, the next things you want to look is this value. We call it F value. This is the value is to test how good is this regression models here, right? So this is how good the linear model this one is. So as you can see, this is what we call is the p-value, right? So the p-values here is 0.01333, right? So the 0.01333 is less than what? This is less than 0.05. Right, so that's why in here they have say the 0.05, they have 1 star. So that's why it's 1 star. That means if you use the significance level at 5, alpha equal to 5, and then in here this is 0.01333, so it's significant, right? So that's why you reject the null hypothesis. So you will say this model is fit, you know, it's fit good, right? So it's a linear model. I don't want to say fit good, but you know, it fit linear model is okay at the 5% significance level. As you can see, we have a lot of variation. So that's why the SSR is kind of big, but in general, it's still, you can see it's a linear models here, right? So you fit good here. All right. So that is the, you know, that is what is the ANOVA fit will tell you. All right. So it will show you. So you will find the SSR and also say, hey, how is this model? So you look at the F value and the P values, right? So remember, this is the p-values, right? So associated with the f-value. So don't forget, this is what is the p-value we use all the time. So if the p-value is less than 0.05, then we say it's significant. That means the linear model do exist here, okay? So, you know, like, you know, during the homework and the exam, so a lot of time they will just give you those table. Then you need to be able to read those table and to find the value you need. And the most of the software used, you know, they have many different software, you know, try to do the linear regression analysis. Most often they will give you the similar information, like all the table we see in here. All right. So the next thing is here, the last statement is here. We want to, you know, we want to take a look at how good is the fit, right? So in here, the F value, the P value say, yeah, this linear model is okay. And so let's see here, how good is the fit? So you use the statement, you say plot, P-L-O-T. If you use the plot and the fit, okay? So when you use the plot and the fit, they will give you 4 different plots here, try to help you to evaluate is your linear model is okay. All right. So here, okay, so you see here to see the next plot. Okay, so let's say okay. So okay, so this is the first, right? So this is the residual versus fitted value. So this is a fitted value residual. So the things you want to see in this graph, what you care about, to see are they randomly jumping around, right? So do they have any pattern, or you know, if they are randomly jumping around, then they don't have any specific pattern, then we know this fit probably is good. All right. And then let's see here, there are several others fit. And so this is, we call this normality QQ plot. That means we said the residual has to fit normal distributions, right? So you take a look here. So all the points, if they are very closely hugging these lines here, right? So if you see these points here, right? So you can barely see these lines, right? So this line. So if all the points are very close to this line, then you will say, hey, this residual is very close to the normal distributions. All right. So my assumption seems this model seems works out good, fit my assumptions here. Then the next ones here, you know, instead of doing the residuals, we do the standardized residuals here. So it's the same thing. You're looking to see if there's any pattern or not, or they are very randomly jumped here. So the last things here, this is we call the leverage plot. That means I want to see, do I have any predictor variable? The predictor is extremely large, extremely small, which have a, you know, the big influence into your, to your y value. So like in here, and we did not see any, and so, and also like when we're not going to cover in this class. So when you go to the next level, right? When you go to the next level statistical class, they will show you the formula how to decide is there's any leverage point or not. But basically, one of the simple, easy ways here, you see this is a 2, right? And this is -2. So most of the one, if they are between 2 and -3 and -2, so it's not affecting too much here, okay? And also the formula will show you, where, like is this one, like this is too far off and or not, is a leverage point or not. But, like I said, for this class, we're not going to cover that. So mainly for this class, the earnings graph, even they will generate, so for when you do let me erase this. Okay, so when you do the plot fit, even you will generate 4 different graphs, but the graph here we care about from our level, current our class levels here, we are care about is just this residual plot to see, as you see, seems like they are jumping pretty random, right? So for example, if your residual plot is something like this, I'm just exaggerate that, right? So if some residual is like this, then your residual is not in a random pattern. So then probably the linear model is not a good fit. Okay, I think we discussed this in the other videos here. Okay, so that's it. All right, so let's go back to our papers here. So here I have a list of all the coding here, right? So the first things here, right? So follow the steps, right? So the first things here is what? First things you do the scatter plot, right? So this is how do you do the scatter plot and the code. After you do the scatter plot, then the next things here, you fit simple linear regression line. You use the app line, see the output like this. After that, you do regression analysis, right? So for the regression analysis, remember the key things we need to be careful is those 2 numbers, right? Those are the 2 key numbers will help you to do what? Decide your regression line, B0 and B1. And also this number we say is important, right? So this is R square. That means it's a percent of the variation of the Y was explained by the predictor, by the predictor variable. So if this one is not too big, that means your model probably missing some important predictor you did not think about. Okay, so then the next things here, after that, you want to see the analysis of the variances here. All right, so the analysis of the variance, the number you should pay attention is this number, right? So this is, so this number, this is what? This is we call the SSR, right? Sum square residual. So it's SSR. So this is just see how much variations you have here. After that, what do you want to do here? So after that, you want to do an analysis to see how good. So you do a plot fit. So you will see these 4 different graphs. Each one have its own purpose. Like I say, for our level, we only care about these ones here, right? So we just want to see the residual versus the fit plot. Are they random or not? All right, so do they have any pattern? Like if they don't have the pattern, then you know probably your regression line fit well. All right, that's it. That's for this videos here. I hope that you'll be able to call back to references the code that I use and how do you do it, right? So just make sure you copy down the codes here, right? All right, that's it. And have fun in using and programming the R. All right, bye. Have a good day. All right, bye-bye.